Okay, today we're going to go talk real quickly about triangle inequalities. The first rule that you saw in your textbook, it said that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if you add any two sides of the triangle up, it has to be bigger than the length of the third side. So I drew a little triangle here. I labeled each side. This is side A, side B, and side C. And the three inequalities that you get, if you add A plus B, that has to be bigger than side C. If you add A plus C, it has to be bigger than the length of side B. And if you add B plus C, that number has to be bigger than the length of side A. So let's go do some examples. Determine if the lengths that are given, if they form a triangle or not. So I'm going to label side A 14 inches, side B is 17 inches, and side C is 25 inches. If you want to go ahead and draw a triangle, you can. So 14, 17, and say 25. I need to check to see if these three measurements will indeed give me a triangle. So let's go add 14 plus 17. What do we get? 14 plus 17. I'm asking, it's not a very good 7. I'm going to ask, is that bigger than, what side's not highlighted, 25? What is 14 plus 17? 31? Is 31 bigger than 25?
31.
And the answer is yes, that works. So now I need to check the other two inequalities. I added 14 and 17 up. Now I'm going to add 14 and 25. Is 14 plus 25 bigger than that third side that's not highlighted? Is it bigger than 17? 14 plus 25 is 39. Is 39 bigger than 17? Yes. I have one more relationship to check. I did 14 plus 17. I did 14 plus 25. Now I need to check, is 17 plus 25 bigger than 14? 17 plus 25, is it bigger than 14? 17 plus 25 is 42. Is 42 bigger than 14? And the answer is yes. All three of those inequalities were true. So you can make a triangle with sides of length 14, 17, and 25. So yes, this triangle is indeed a triangle. Now you go practice. If you have a triangle that has lengths 4.1 centimeters, 2.2 centimeters, and 8.3 centimeters, is that a triangle? You need to go check. I would start with these two sides, add them up, and is that number bigger than 8.3? Okay, I paused the video and gave you some time to work. So you were supposed to check, is 4.1 plus 2.2, is it bigger than 8.3? And you went over to the side and did 4.1 plus 2.2. You lined up the decimals. 1 plus 2 is 3. 4 plus 2 is 6. So you saw that 6.3, is it bigger than 8.3? And you said, no, it wasn't. That's not true. So this cannot be a triangle. And if you get a ruler out, okay, if you get a ruler and you draw a length of, was it 8.3? About right there. And then you draw from this end a length of 4.1, and you draw from the other end a length of 2.2. So here's 2.2, about this long. Do you see that if you try to make a triangle with that red, blue, and orange lengths, that does not form a triangle. You're too short. They won't connect and make, you can't ever make it look like this. Those red and blue links aren't long enough. Okay, so let's go do it again, one more time. What if you have a triangle, or I should say this, can you have a triangle with lengths 6 feet, 6 feet, and 12 feet? So I'm going to go draw it. Ooh, I noticed that it's an isosceles because two of them have the same measure. It's an isosceles triangle if it's a triangle. Okay, I'm going to start with the two smallest sides and check that inequality. Is 6 plus 6 bigger than 12? 6 plus 6 is 12. Our inequality that we're checking, is 12 bigger than 12? And the answer is no. I see some head shaking. That is not a true statement. You cannot do a triangle like that. In fact, if you did it, here's the one that has the length of 12. If you started on one side and did a length of 6, and on the other side you did a length of 6, you would just have 3 flat lines on top of each other. There would be no angle. You could never actually make it look like that. Okay, on the last two examples, I did not continue on and show you like 6 plus 12, is it bigger than 6? And then is 6 plus 12 bigger than 6? I didn't have to go to those other two inequalities because I found an inequality that was not true, and I stopped there. All right, new concept. Next page. All right, last concept for today, the relationship between an angle and its opposite side. So when you talk about a scalene triangle, and if you remember what does scalene mean? It means that all three sides have different length. Okay, in a scalene triangle, the largest side, or I should say the longest side, is always opposite the biggest angle. And you know that the shortest side is going to be opposite the smallest angle. So if you have a triangle, and I've drawn a triangle, the three vertices are A, B, and C. And we usually denote the vertices of a triangle with capital letters. And then if we look at the sides that are opposite, this would be side little a. This would be side little b. And this would be side little c. So if you were looking at this triangle and you knew that this was the longest side, which angle would be the biggest? And it would be angle A. If you knew on this triangle this was the shortest side, then angle B would be the smallest angle. Angles in the opposite side, there's a special relationship there. The longest side has the biggest angle. So let's go do an example. Let's look at the black triangle. It says to order the sides of the triangle from least to greatest side lengths. In that triangle, which angle has the smallest measure? The smallest measure is 53 degrees, side or angle S. This has the smallest angle. So over here, that would be the smallest side. So RT would be the smallest length. And I'm going to put some less thans here. There's 3 side lengths, right? That's what I'm comparing. I found the smallest angle, so the smallest side is, the shortest side is RT. Now let's go find the biggest angle. Where is the biggest angle? 65, 62, 53. This is the biggest angle, angle R. So the longest side would be right there, opposite the angle. So ST or TS, either way, would be the biggest. So which side it would be in the middle? We've done the smallest, we've done the biggest. The one in the middle is angle T. So the side in the middle would be side RS. Now let's go do the red triangle. I have the smallest side, the middle side, and the biggest side. You go practice. All right, so we want to find the smallest angle first. We have a 38-degree angle, 113-degree angle, and a 29-degree angle. So the smallest angle is here. What side is opposite that angle? Side AB is the shortest side length because it's opposite the smallest angle. Now I'm going to go after the middle side length. So I've already used that one. Oops. I've already used this one as the smallest. Which one would be the middle angle length or measure? 38 degrees or 113 degrees? This one is the middle. So the side opposite angle A is side BC. That's the middle length side. One more, now that I've already used this. The largest angle is angle B with 113 degrees. So its opposite side is the longest side, and that's side AC. Okay, I gave you the angles. You had to put the side lengths in order from smallest to biggest. Now I'm going to give you the side lengths, and you have to put the angles in order from smallest to biggest. So here on the black example, you've got 3 angles you've got to put in order from smallest to biggest. Which side length is the smallest? 5 inches, 13 inches, or 12 inches? The 5 inches is the smallest. The angle opposite this side is angle N. It's going to be the smallest angle. Okay, this one is finished. Which one is the middle side length? Which one's smaller between 12 and 13? Right here at 12. So the angle opposite side LN, which is right here, is the middle angle measure. So now we use the 12. The biggest side was 13 inches. That was the longest. The angle opposite that side was angle L. Angle L is the largest angle. Now you go do the blue triangle. Put the angles in the right order from least to greatest. Okay, one more time. We're going to go find the smallest, the shortest side length. 1.2, 2.3, and 1.9. The smallest is 1.2. That side is opposite the smallest angle. So angle Z is the smallest angle. Now I'm going to cross out the 1.2. I've already used it. The middle side length is 1.9. The angle opposite that side is angle X. That's the middle angle. Now I've already used the 1.9. My longest side length was 2.3. It's opposite my largest angle, which is angle Y. I hope that going over the relationship between the angle and its opposite side, and then also looking at the triangle inequalities, I hope that helped.